What's up, guys? AP Calculus AB, product rule for derivatives. We're going to start with a function f of x, which is 1/3 x to the fourth, just picking a function that you should know about and how to find the derivative. In class, we talked about it. Let you guys think about it for a little bit. Remember, the power rule for derivatives says that you multiply the exponent and the coefficient, and then you subtract the exponent by 1, 4/3 x to the third power. We also need to remember some other rules here. So here's another function, 1/2 x squared plus 2x, a little backstory working our way from a state of you understand to, well, what's next? You can take each of those terms' derivatives in pieces, and then after you've found it, there you go. Hey, g of x equals 4 to the x, 4 times x to the 1/2 power. Well, remember that is also square root of x, so we're kind of answering the square root derivative at the same time. But you still can multiply the exponent and coefficient and then subtract the exponent by 1. The power rule shortcut works for root functions. And then you should probably rewrite it, positive exponent or something. Continuing our journey down the review of certain types of derivatives, like what is the derivative of 2 times square root x? And maybe you remember the shortcut that directly takes you from square root to its derivative, or you work your way through the converting the square root to an exponent and then solving. Here in this one, that's the trick that I show and then use it. But you might also want to remember that the derivative of square root of x is 1 over the quantity, the product, 1 over the product of 2 root x. And then if you're going to multiply by 2, it's kind of like the 2's cancel. How about cube roots? Do you know how to find the derivative of a cube root? I promise we're getting a product rule next, but we're just kind of working our way back through some common derivatives, some common functions that you should know how to find the derivatives of. A cube root of x, we can write as x to the 1/3. We can use the power rule shortcut to multiply exponent and coefficient, and then subtract the exponent by 1. A little rewrite, and also remember some exponent properties lets us go ahead and pull the 2 off of the 2/3, making it be x squared. All right, next up for us is, let's actually get into product rule. Let's tell you we have two functions, like f of x equals x squared, and g of x equals the square root of x. Now, we should be able to use some of our shortcut properties in order to simplify that. We know that the derivative of x squared is 2x, follow the rule. And we've talked about it enough already in this video and in that lesson about what the derivative of square root is. Using the power rule shortcut or using the limit definition shortcut, we do wind up producing 1 over 2 root x, 1 over the product of 2 root x. So what happens if you multiply those two functions? You do x squared times the square root. If you're thinking about it, if you're savvy with your exponents, then you should know that it's x to the 2.5 power, and then you could just find the derivative using the power rule. But something else to consider, as well as using two products or use the product of functions that are tangible, is that we can work through this thing called the product rule for derivatives. Literally, if you're taking the derivative of f times g, two functions, then its product rule is going to be f prime g plus g prime f. The y part of it is part of our discussion. We'll get to there eventually. But right now, just know that it works for us. And we're looking for kind of like a cross action of multiplying the derivative of f times the full parent function g, and then adding to that the derivative of g times the parent function f. And wouldn't you know it, we actually do wind up with the derivative. 2.5x to the 1.5 power. Hey, I know the video is cut out. We're done this time, but thank you for watching this video, and stay tuned for some other ones regarding functions and their derivatives from calculus. See you in the next video. Bye.